Okay, I'll start with a question for the floor. Does anyone know what the following locations have in common? Rochford? Billericay? Anyone? Unfortunately, they're all locations where we've had on-track plant collisions during the last couple of years. Unfortunately, again, in one of those incidents, one of the operatives encountered life-changing injuries. But that's why I'm excited to be able to share with you some of the safety innovation that we're currently delivering for on-track plant. So for the next 15 minutes, I'll just take you through the areas I'm going to cover. I'd like to give you a background to the development. I think it's important to understand how it started, why it started. I'll give you an overview of the features of the collision avoidance system. You'll see a small animation. Hopefully it won't be the Quattro one, but you never know. And then I'll talk to you about the development work that we're doing about the isolation limit control system, and then just give you a general update on some of the approval status and the progress. So the system was developed, or started its development in January 20. It was one of our directors, Peter Gray. He was driving to work that morning, this sort of time of year, so the conditions weren't great. And a vehicle in front of him swerved, went in front of him, and before he could even react, his car took over the control, alerted him, and slowed him down. He thought, right, I know what I'm going to do when I get into work. So he got some of his fellow directors from Elmec plant, which is one of our sister companies, and the directors from the R&D, and said, I want this going on my plant. I want to make our plant the safest, and he wanted that as a USP. But as part of the natural development, we engaged with all the right parties, Network Rail being a significant one, and Network Rail said, no, actually, we want it on our plant, and we'll work with you in terms of the approvals to make that happen. So later that year, in the December, we conducted some successful trials over at Tuxford, observed by Network Rail and other parties. And then the following year, or earlier this year, we were actually instructed to implement the collision avoidance system on 2 SRSs and 2 Geismars. And we worked. We've currently got the approval for the SRSs, and we're very close to the Geismar as we speak. So just a little overview of the system before I show you the animation and really bring it to life. The system's actually integrated into the plant. It provides visual and non-visual, so visual meaning it's got high definition cameras for the operative, but it also got radars. It's got activation in terms of it communicates with a human-machine interface pad, so it tells the operator if it's approaching any object within the W6 gauge. It's also has a data logging system, so it actually records all the video and all the activities that the operator conducts. It limits the speed to the worksite mode, so hence it avoids the operator speeding in the first instance. If it sees an object within a set parameter, it brings the vehicle to a pause. So what I'll do now is I'll move over to the animation.
Hastech Rail, proud to be improving safety through innovation and collaboration. Hastech Rail have successfully developed and commissioned an on-track plant collision avoidance system, otherwise known as CAS. The Hastech CAS technology is integrated into the on-track plant's control system and has several embedded enhanced vehicular controls to limit both the worksite and travel mode speeds. Upon wheel engagement to rail mode, the camera, radar and exclusion zone light, which can only be seen in low light, will be active when travelling in the forward or reverse directions. Worksite mode will be activated by default. All activities undertaken by the on-track plant are displayed on a human-machine interface pad. All activities are video recorded and data logged via the CAS secure protocol, with a copy available upon completion of the shift. Travel mode. The CAS has detected that the vehicle travel mode speed limit of 10 miles per hour has been exceeded by the operator and automatically slows the vehicle in a controlled manner back down to 10 miles per hour. The speed limiter, which is integrated with the CAS, is configurable at the point of installation. The maximum speed limit is set and locked and cannot be adjusted by the operator or asset owner. Worksite mode. When set to worksite mode, the vehicle will be restricted to a speed of up to 5 miles per hour. If a vehicle or object is detected within an 8-meter distance and W6 gauge by the radar, safety zone, an audible alarm and warning lights will be activated. The on-track plant will come to a gradual stop within 6 meters braking zone distance of the vehicle or object. A vehicle has been detected by CAS and automatically the RRV will be brought to a gradual stop. Any event that activates the radar system is automatically data logged by the CAS. Additional CAS features include automatic reset functionality, allowing the vehicle's drive system to be re-engaged if the object is no longer detected, permitting the driver to commence travelling or other activities. CAS also features a manual override button, situated in both the cab and basket. This allows the machine controller only to permit back-to-back working when specified. Any activation of any override available within the system is automatically logged within the CAS data logging technology. CAS also includes an emergency recovery procedure, with a master override switch being located on the control panel. This disables the CAS to enable vehicle removal from site in case of equipment damage. Hastech Rail, proud to be making the railway a safer place to work.
Okay, so one of the key things to know is this doesn't replace or take away any responsibility from the operator. But what it does do, it provides a lot of intuitive systems and controls in line with what they should be working and operating the vehicle to, both that and the machine controller. So just a little recap on some of the key functionality. Basically, once the ignition's turned on and the rail gear is activated, the system's turned on, the data logging is there, and you're set to worksite mode. So the principle is that all plant, when it comes on the wrap, should be accessing within a worksite, as general principle, and therefore, why not set it to the current speed? Yeah. All activities are data logged, so in the conversations during the course of this morning, a few examples or industry challenges that we face where we have an accident or an incident or an event, and it takes weeks to try and collect the relevant information, and you never guaranteed that you've got the right information to understand what the root cause is. The issue of the transparency around the data recording was something that we thought was going to be a concern for operators, but as we started to conduct familiarisation training with Network Rail's OCR team, they're actually welcoming it. They're actually saying, great, you know, that's what we want. We want that. We want the controls. And they were very embracing it, which was great to hear. So, like I say, the camera and the radar is activated in the direction of travel. Yeah. If an object is detected, then the power is the acceleration, is released, and the brakes gradually come on. And that's what that does is it avoids the operator conducting an emergency stop. So it brakes and it complies to the 1530 regulation for plant. Again, one of the other features that we've developed and modified in conjunction with Network Rail was the creep mode. So this is where, when you're working out of a basket in certain activities, certainly in the OLE profession, there may be a requirement for two pieces of plant to go back-to-back working. So in that case, CAS would be activated, but it would be in a controlled way. Then the override would be applied, but we've limited the override speed, or the creep speed, to 1 mile an hour. So it's easier for the operator to actually get closer to the adjacent machine or to any other work location he needs to get to. So what I'd like to do now is just tell you about our latest development, which is, again, an integrated part of the collision avoidance system. It's the isolation limit control system. You're probably all aware or not aware that on the 19th of November, this new standard was mandated. As my understanding, it came into force after an unfortunate event where someone got electrocuted. Basically, it's a reminder of live exposure to the overhead line. There's 4 different types of notifications. There's the picture to the right, where a notification is clicked to the rail. There's also one where you can put a cone in the forefoot. There's one that hangs off the earthing strips, but there's also one that is actually stuck to the gantry as well at the extent of the isolation. So what we've done is we've developed the CAS system to recognise the isolation limits and identify when it's approaching the isolation limits with within 20 to 30 metres, depending on the range of the Wi-Fi. So the actual on-track plant CAS system has its own Wi-Fi, so it's not dependent upon any other third Wi-Fi, but the range is 20 to 30 metres. And once it hits that parameter, it starts to break again. Again, if there is a requirement to creep to the extent of the isolation, then the 1 mile an hour creep activity is available. Again, all these activities, just like the CAS, all data logged, and all the evidence is obtained. The receiver at the bottom there is viable for 100 hours. We've tested it, and you get various power supply systems to charge that up. We've also, as part of some of the feedback with some of the maintenance staff, they identified that as part of rolling out this system, it was starting to take them twice as long to take the isolation because they needed to carry nearly twice as much equipment with the different signs. So what we've done is we convert some basic straps just to help carry them, and it seems to work. So just recap, basically you'll see there that the isolation warning system again comes up on the human-machine interface pad. Yeah. That's on detection, and all the audible notifications again all come up. Very similar sort of principles and concepts to the CAS, it's just that it's conveying a different message. Yeah. So finally, just a recap on where we are in terms of product approval. I know, again, that's a common question and or challenge to us all. With respect to the CAS system itself, we've gone for a PA for the CAS as a black box concept. We received trial certification back in May. We've conducted and undertaken all the tests in accordance with the trial, and it's currently sitting with Network Rail for approval. But in the interim, we've had the certificate extended to April next year. We've got PAB approval for 4 SRSs, 2 of our LMEC plant and 2 of Network Rail's SRSs. The Geismar is imminent. We've also been contracted to complete the OCR fleet of SRSs and also their fleet of 12 Skyrailers as well. With respect to the isolation limits, we've conducted a number of trials, again evidenced by Network Rail and TUV, who's our approval organisation. We've got a trial certificate, assessment application drafted, and that will get submitted shortly for review and hopefully acceptance of the trial, and then we'll conduct further trials and hopefully get that approval in place shortly. So we're really proud, and we do believe this will save lives and injuries, but the more we roll it out, the more we'll reduce the risk.